Section discusses general angles and radian measure. And the beginning of the section talks about angles in standard position. In the previous section, we worked only with acute angles, angles measuring between 0 and 90 degrees. And in this lesson, we will study angles whose measures can be any real numbers. Recall that an angle is formed by two rays that have a common endpoint called the vertex. So in the figure, you can see the two rays they're referring to are this blue ray, labeled the initial side, and this blue ray, labeled the terminal side. And the common endpoint, the vertex, is what we think of as the origin of this XY coordinate system. You can generate any angle by fixing one ray, called the initial side, here, and rotating the other ray, called the terminal side, about the vertex. In a coordinate plane, an angle whose vertex is at the origin and whose initial side is the positive x-axis is in standard position. So in this figure, this angle, identified by these blue sides and then this arrow indicating the angle rotation, that angle is in standard position because the vertex is at the origin and the initial side is the positive x-axis. The measure of an angle is determined by the amount and direction of rotation from the initial side to the terminal side. The angle measure is positive if the rotation is counterclockwise and negative if the rotation is clockwise. The terminal side of an angle can make more than one complete rotation. So for example, when I look at this angle again, I've got the initial side here at the positive x-axis. Vertex is the origin. Here's my terminal side. So that's an angle in standard position. The arrow indicates the rotation, and that arrow is indicating a counterclockwise rotation. The angle measure is positive if the rotation is counterclockwise. So this angle measure would be a positive value. The last sentence, the terminal side of an angle can make more than one complete rotation, simply means that I can have angles that measure greater than 360 degrees. If I continued this red arc back around to the initial side so that the terminal side was coincident with the initial side, that would be a 360 degree angle. But I can actually go beyond 360 so that this red arc could rotate an infinite number of times around. So in this example, draw an angle with a given measure in standard position, then tell in which quadrant the terminal side lies. So if I look at the angle, the sign of the angle identifies what the direction of rotation is. So negative angle means a clockwise rotation. Now starting from the initial side, the positive x-axis, since we're measuring these in standard position, initial side is positive x-axis. The rotation is 120 degrees clockwise. Well, 90 degrees would make the terminal side lie right along the negative y-axis here. 120 degrees means I'll have to go beyond that negative y-axis. So here in the third quadrant, I could indicate my terminal side, and here's my angle of negative 120 degrees. These are sketches. They're not exactly 120 degrees if I took out a protractor, negative 120 in this case, but they're approximations. So in the second example, 400 degrees, the positive indicates that it's a counterclockwise rotation. So starting on the initial side, the positive x-axis, I'm going to rotate in a counterclockwise direction. Now I have to identify where I'm going to draw the terminal side. Well, I know that if I go all the way around the circle, that's 360. To get to 400 degrees, after 360, I need to go 40 more degrees. So that would place this terminal side here in the first quadrant. So here you see two problems. You could pause this presentation and try each of these. Draw an angle with a given measure in standard position. So for 144 degrees, the positive indicates a counterclockwise rotation, the fact that it's positive 144, a counterclockwise rotation. The initial side is here along the positive x-axis because this is standard position. If the measure were 90 degrees, the terminal side would lie right along the positive y-axis. If this were 180 degrees, the terminal side would lie here along the negative x-axis. So 144 is between 90 and 180. My terminal side lies here in the second quadrant. For number 30, negative 15 degrees, the negative sign indicates a clockwise rotation. And 15 degrees, that's going to place the terminal side here in the fourth quadrant. Initial side, again, that's the positive x-axis. Definition of coterminal. So in this example, the angles 510 degrees and 150 degrees are coterminal. Two angles in standard position are coterminal if their terminal sides coincide. An angle coterminal with a given angle can be found by adding or subtracting multiples of 360. So these two angles in standard position, 150 degrees, indicated by this green rotation arrow, and 510 degrees, indicated by this red rotation arrow, those are coterminal. They're both in standard position. Their initial side is the positive x-axis. And they're coterminal because their terminal sides are coincident. Their terminal sides are located in the exact same location. If I rotate 150 degrees, my terminal side here in the second quadrant. If I rotate 510 degrees, I go all the way around, that's 360. Another 90 would be 450, and then another 60 degrees will put me in the exact same place for this terminal ray. And you can see what they mean by adding or subtracting multiples of 360. I go 150 degrees to get to the terminal side here. And then if I add 360 at this point, all the way around, 150 plus 360, that's how I arrive at 510. So here in the example, find one positive and one negative angle that are coterminal with, well, part A is negative 100 degrees and part B is 575 degrees. So for negative 100 degrees, to find a positive angle coterminal with negative 100, I can add 360. The resulting angle is 260. So negative 100 and positive 260, those are coterminal. To find an angle that's coterminal with negative 100 and is also a negative angle, I could subtract 360 from negative 100. Negative 100 minus 360 is negative 460. So negative 460 and negative 100, those are coterminal angles. For 575 degrees, well, if I subtract 360 from 575, that'll still be a positive value. So by subtracting 360, I can get a coterminal angle, an angle 215 that's coterminal with 575. In order to get a negative angle that's coterminal with 575, I'll have to subtract a greater multiple of 360. So instead of 1 times 360, I'll have to subtract 2 times 360, or 720. Then when I take the difference, 575 minus 720, the resulting negative angle, negative 145, is coterminal with 575. I'm going to pause this movie and continue this lesson in a second video.